Next speaker is Carl Sharman from CrowdStrike. Threat hunting is not an abstract idea to Carl, as he began his career as an Air Force intelligence officer and continues to serve in the Air National Guard as the Director of Operations for a cyber intelligence squad. Prior to joining CrowdStrike, he worked as a threat intelligence analyst at the Washington State Fusion Center and the Department of Energy's Pacific Northwest National Laboratory. Please welcome Carl Sharman.
Thank you very much, Rich. Sounds like this is on. Good to go? All right. Thanks. Well, it is absolutely a privilege to be here and be a presenter at the first ATT&CKcon. So thank you, MITRE, for this opportunity. I'm going to be talking today about analyzing targeted intrusions through the lens of the ATT&CK framework. I work at CrowdStrike as part of our Overwatch team. That's our threat operations team, threat hunting operations team. And we began adopting ATT&CK late last year, early this year, to help us better understand, better categorize and track adversary TTPs as we were observing them in the wild. And so what I'm going to talk about today is how we implemented that process and some of our findings so far to this point. A little about me. Rich talked about my background. I'm a family man. That's my family there. I'm a beautiful wife and beautiful young girls. I have to give a shout out and thanks to James for his presentation this morning and giving me that dad joke. One thing, if there's anything I've learned as a dad, you can't have too many dad jokes in your inventory, so greatly appreciate that. Also, I have to thank MITRE for the trinkets in the swag bag, because another thing I've learned being a father, it helps if you can bring back some gifts if you're away on a work trip. Come back and you don't feel as guilty if you can bring back something nice for the kids. But my wife has made that a bit more challenging. She's banned any candy and stuffed animals now. We have too much of that stuff in the house. And so now I've got a great spin on the classic game of bingo to bring, as well as a great big flag that the kids can have fun with flags. So yeah, it's been a successful trip, I would say already. Okay, so I'll talk about the overall project, this process of how we are implementing and using ATT&CK for our threat hunting operations, give you some results overall from a high-level summarization of what we found so far, pull out some interesting examples of technique usage that we've seen in the wild for each of the different tactic families within the ATT&CK framework, and then draw some conclusions at the end. Okay, so the project overall, why did we begin using ATT&CK? What was our goal for performing that type of research into our intrusions? Well, first of all, we wanted to develop a strong baseline for adversary TTP usage we were seeing in the wild. As has been talked already in this conference, it's very helpful to have a common taxonomy, a common standard language or framework to work from when you are analyzing and categorizing tactics over time. Prior to implementing ATT&CK, when we would make assessments on changes in TTP trends over time, those assessments were somewhat subjective because we didn't have that standard common framework to work from. So we're anxious to be able to implement ATT&CK because it was going to meet that need for us. And from that point forward, when we have an established baseline of TTP usage, we could accurately and confidently measure changes in TTP usage into the future. So that was a benefit. Also, we were hoping that we could develop some more robust adversary profiles. When we observe adversaries performing intrusions against our customer networks, we could plot their tactic and technique usage using ATT&CK, build those profiles for each adversary. I know that sort of analysis is already available open source through the MITRE website, and using the ATT&CK Navigator to visualize that, all that's good stuff. But we wanted to do that same sort of analysis based on our view of the world, what was available in our customer data set and how did that compare to what's open source. So another way we could use this ATT&CK framework to better get an understanding of the adversaries we were seeing. So that was the other objective of implementing ATT&CK for us. And how did we go about that process? Well, first of all, it was pulling out all of the data surrounding the intrusion we were finding. So when our threat hunters would identify an intrusion, they'd do their initial triage, analyze it, report findings to the customer, and then after the fact, we would go back and analyze all the individual command line executions for all relevant process trees associated with that intrusion. So it can be a bit laborious of a laborious process, but we wanted to analyze all the command execution, everything that was happening during the attack, and compare that to what we know of techniques that are listed in the attack framework and plot those and chart those over time within the intrusions themselves. So a lot of tracking went into, and a lot of human eyes and review to go in and review these intrusions as they were happening. You can see the MISP logo up there. We used the MISP tool as a way of actually tracking the TTP usage for each of our intrusions over time, so that was very handy for that purpose. And for clarification, I should point out that we were as consistent with our mission in the Overwatch team doing our threat hunting. We're looking only at those targeted intrusions, those advanced and or persistent, more sophisticated adversaries trying to fly below the radar on our customer networks. And whether it be traditional state-sponsored motivation or also criminally motivated adversaries as well, but those that are considered targeted intrusions are what we're primarily looking at, not the other threat types that are out there. And there were certainly some challenges in going about this process. First of all, understanding intent. As we were plotting tactics and technique usage among adversaries, we were concerned not just with the techniques, but also the tactics. What objectives were they trying to accomplish while performing these techniques and these procedures? And sometimes that could get a little bit difficult because, as you know, some techniques fall into more than one tactic family. And so when we see an adversary using scripting, well, are they using it for defense evasion purposes to try and hide maybe what's going on within the script? Or are they executing scripts for the purposes of facilitating easier, quicker execution? Sometimes it's hard to judge that intent. So that was certainly a challenge. Another challenge was the potential for human error because, like I said, we're going through and reviewing these command line executions at length. There's a lot of data to go through, and we wanted to be as accurate as possible. So we were looking at that with human eyes. So there's certainly a potential with the volume of data we're looking at that perhaps we missed something or perhaps we mislabeled something. Where that is a possibility, we definitely tried to minimize that as much as possible. As a side note, we are working and exploring different ways that we can automate a lot of this categorization and tracking. We do that a little bit, but as James's presentation pointed out this morning, there are potential pitfalls in some of the automation, so it also helps to have human eyes on things. But perhaps next year we can talk more, explore and consider presentations that talk more about how we can better automate analysis using ATT&CK. All right, what were the data results of what we've found so far? High-level summary here as we get started. We looked at all of our intrusion cases starting in January, and we're continuing to do it to this day, but for the purposes of cutting this off for packaging our presentation up in a nice format here to deliver to a public audience, we cut our data off at the end of July for what we're going to present. During that course of time, I analyzed numbers and numbers of intrusions in the wild, and what we saw in the course of all those intrusions were over 1,200 instances of a technique being used at least one or more times in the course of a single intrusion. And when you added that up and plotted that out across the entire matrix, there were over 151 technique types used total during the course of those 7 months. And so if you remember, when you look at and again, I'm talking primarily about, exclusively, I'm talking about the attack for enterprise framework here. I'm not talking about pre-attack or attack for mobile, some of the other, I'm talking strictly attack for enterprise, could be Windows, Mac, or Linux. That's the attack matrix I'm referring to here in this analysis. But again, yeah, we saw 151 total technique types used in the wild by true malicious adversaries. And based on the total number of techniques, which is well over 200, we saw over half techniques used during the time period, which was pretty good. From our sense, it emphasizes the rich data that we get to have visibility into. Another quick summary chart there on the left just shows you the different threat types that we observed in this data set. Almost half were considered state-sponsored adversaries that we attributed those intrusions to. A smaller percentage, about 20%, 19% were criminally motivated, targeted adversaries, and then the remainder were unattributed. And as far as intrusion cases go by operating system, that's the other chart there. The vast majority were Windows enterprise networks where we identified the activity with a small percentage there of Mac and Linux. That's been changing here in more recent months. Like I said, we cut the data off at the end of July, and we're definitely seeing a bit more in Linux and Mac these days than what was happening earlier in the year. And I should also clarify, that this is just what we've seen on our customer networks. With our view of the world, we're not trying to project any global assessments or global trending based on these findings. This is strictly what we're seeing on that more limited scope. And some of you out there are members of different verticals, and so based on industry vertical, we wanted to share some of our findings, give you a sense of what that has looked like as far as where we're seeing these intrusions take place. A lot happening in the technology space, professional services industry as well. Not as much, at least to this point this year, in verticals where we've seen higher percentages in years past. Look at like defense or biotech, pharmaceuticals, not quite as much there happening so far this year. But again, wanted to give you some of this context as we dive into some of the more specifics. Okay, I know this is zoomed far out and hard to read, so you don't feel like you need to read all those individual lines. We're actually going to zoom in and look at each of these individual tactic families by themselves. But to give you an overall view of what this looks like when we plotted out a heat map to look at the entire matrix, the darker color red means that's the more often we've seen it. We've seen the tactic, and then if it's grayed out, that means we didn't see it. And then you have all the shades of red in between. And the darkest colored red techniques are the ones you certainly expect to see most often, command line interface. You're going to see that in a vast majority of the intrusions. That's because an adversary is going to want to get shell and perform their command line execution. So that's commonly seen, and that dark of red means we've seen it well over 50 times, 50 different intrusions. That would be the higher end, and that's the minimum for that color of red, so you could go up even further than that. And then the different shades of red are different level of frequencies going down from there. I won't spend too much time talking about the breakdown in colors, but to give you a general sense, that's where the colors are coming from. So let's dive into each of these individual tactic families now. Talk about initial access. So when you look at the heat map for initial access, the most commonly used technique we saw certainly was valid accounts. Again, we're not saying this is what the most common technique is globally among targeted actors. This is strictly what we're seeing, and keep in mind that we are performing threat hunting operations. So we're looking for adversaries already on the network who are flying below the radar. And so in a lot of those cases, or maybe we're coming in a lot of times, we're brought in a post-exploitation scenario. And so that's why we see adversaries who have already been on the network, they've already done their credential harvesting, and when they come back and return and we catch them, we see them, they've already compromised those credentials and they're using those valid accounts to return to the network. An example here to call out is a case that occurred against a think tank organization where they used a spear phishing link technique to target that organization. Not the most advanced technique, but the method in which they used social engineering here was interesting. The purported user was a university professor who persona that was reaching out to the victim, and they reached out to this victim because the victim was an expert in global economics, and the university professor claimed to be holding a class on that particular topic, and they wanted this victim's expertise to participate in the classroom discussion. And so the victim, thinking this was a legitimate university professor email account it was coming from, agreed and was honored to be asked to participate as an expert in the class discussion. And so in return, the university professor persona sent a spearfish email with a link to download the teleconferencing application software that was needed to participate in the class discussion. And the user did so and installed the teleconferencing application. However, also along with it, some malicious backdoors. So that's what happened there, and we're sharing that just to again emphasize that the creativity and the lengths that social engineering that adversaries will go to is definitely remarkable in some cases. As further research, good research that our Intel team did, found that a similar sort of campaign was also used to target employees at Bitcoin exchanges wanting to use their expertise in digital currencies to take advantage of getting access to those organizations as well. So a reminder to be on the lookout for those more crafty social engineering campaigns that are out there. Execution, again, when you look at the heat map, this is the sort of stuff you would expect to see based on the way the matrix is set up, command line interface, PowerShell, WMI, you're going to see a lot of that stuff. But also saw smaller instances of other techniques as well. The one I'll call out here is the install util technique. A lot of people are probably familiar with this, but we have certainly seen it. And in this case, we saw it against an organization in the technology and entertainment industry where a Panda adversary, Pandas are reference to Chinese-based adversaries, performed this attack where the adversary already had access to the network using valid credentials. They actually were accessing the network via TeamViewer, which is legit remote administration software. They were accessing the network through TeamViewer, but they wanted to establish redundant access, so they wanted to get another implant installed in case they were going to lose that TeamViewer access. And so what did they do? They employed the install util technique. Install util, legit Microsoft binary that when executed will run .NET executables, and it bypasses whitelisting while doing so. So in this case, when they ran it, they used it to execute a malicious DLL that had been recompiled in .NET. And when they ran that .NET executable, it turned out to be a variant of plugx. And so they ended up sideloading plugx through a legitimate Flash player process and got execution, got their backdoor working through that method in this case. Next, we'll talk about persistence. A lot of different options here of things to choose from, but I chose to call out a case where hidden files and directories were used for the purposes of persistence. In this case, an academic organization was targeted by a criminally motivated adversary. That's the spider nomenclature for our criminal adversaries is the reference that we use there. And in this case, again, the adversary already had access to the network. They had valid credentials, were logging in via RDP onto the network. And in this case, they targeted a particular machine on the network to install a coin miner. And when they installed the coin miner, they then used the attrib command to go to great lengths to hide it. They didn't just use the H switch to hide it. They also used the R switch to make it read-only, and used the A switch to make it archivable, and they used the S switch to make it a system file. All these things to hopefully cover their tracks in case someone was coming through, conducting forensics, looking for something, they'd see all those file attributes and hopefully pass by and not see it. Again, not the most advanced or sophisticated technique, but another trend that I wanted to point out. However, in the roundtable yesterday morning, I think it was Devin already talked about how cryptocurrencies have become much more popular amongst criminally motivated adversaries as opposed to ransomware. So that's been talked about at length. So thanks, Devin, for stealing my thunder. I'll just move on. Privilege escalation. Here, the example I'm going to pull out is bypassing user account control. And this was a case where we were again called in after exploitation had already occurred, and we observed Helix Kitten, an Iranian-based adversary, was present on this network for a travel and professional services organization. And in this case, they had an implant running on the machine, but when we rolled out, our CrowdStrike Falcon sensor killed the implant in an automated fashion, so it was no longer working. The adversary somehow became aware that their backdoor wasn't working, but they, again, had redundant access. You're noticing a theme here. These adversaries are very good about redundancy in their access. And so what they did is, shortly after they realized that the implant was no longer working, they accessed the box using valid credentials over PS-exec. And when they did so, they attempted a number of different techniques and methods to try and get their implant working again, trying a number of different measures in troubleshooting to get that implant running. And they couldn't quite figure out what was going on. So one thing they did is they tried to modify the registry through this command line here. And what that essentially does is disable user account control remote restrictions, which is a feature of Windows Vista on up, where if you log in over a network logon to a remote machine, and even if you're using an account to log in that is on the local in the local administrators group, if you're coming over a network logon, you're still not going to have admin rights on that. So they wanted to get around that by removing those remote UAC restrictions. And they succeeded in doing so. They bypassed that UAC for the purposes and they did escalate their privileges to admin. And so at that point, they thought they were going to work, they'd finally be able to get that implant working well. It still didn't work. They never realized that it was because the Falcon sensor was there, so they eventually just gave up and moved on to another machine, trying other things. All right, defense evasion. Again, another case here where there's a whole lot to choose from. But the example I wanted to pull out and highlight here is using the file deletion technique. This is against an organization in the an academic institution, and an unknown adversary used a number of different defense evasion techniques that were remarkable when you look at them in concert with each other. So file deletion in and of itself, not all that advanced, but what we saw here was in compilation a number of different techniques that were quite remarkable and notable. First of all, when the adversary was targeting different machines, they were quick to use multiple different types of open source shells. And they'd use one type of open source shell on one machine and not use it very long, and then get rid of that shell and move on and do other things to other machines using other tools. So they had a very heightened sense of operations security. They were definitely trying to evade defenses. So in this case, one of the target machines they went after, they employed a different open source shell, in this case, the Cactus Torch shell, which some of you may have heard of. It's essentially a JavaScript-based shellcode launcher. It uses the .NET to JScript technique to load malicious .NET assemblies into memory for injecting shellcode. And so that's what you see happening in the first command line. They executed it as a scheduled task, but essentially they're using it in the context of a C-script process. And that osww.js file there, that .js file is the one associated with the Cactus Torch implant. So they get it running as in the context of that C-script process, but then shortly thereafter they use file deletion to delete that .js file artifact. So they delete the artifact, but the shell is still running in the context of that C-script process in memory. And so just another case of one of many other things that happened in the course of this intrusion where the adversary just had a very heightened sense of security, wanting to keep as low a profile as possible, make defenders have to work that much harder to find and remove them from the network. And so it was significant from our point of view, the number of ways they were doing that. Okay, credential access. We see credential access, credential dumping in particular, very often in the attempts that adversaries use to gather credentials. But there was one case in particular against a think tank organization this year that stood out among the others, and that's because the adversary demonstrated far greater intent to gather credentials than what we'd seen in other intrusions. And by that I mean they used several different techniques all in the course of the same intrusion to try and gather those credentials. It was obviously an extremely high priority for them. And so they used credentials and files technique, credential dump, multiple sub-techniques of the credential dumping technique, and also Kerberoasting, all in the course of the same intrusion. So some examples there of the command lines we saw that were doing these things. The first command line is a case where they are copying the group policies preferences files from the domain controller. So that would be classified as part of credentials and files for the attack technique. And with that, you can take those group policy preferences files offline for mining and for gathering further account information. In the next example, this is one of several credential dumping techniques that they used. But in this particular case, they actually downloaded the legitimate Windows sysinternals AD Explorer tool. And with that tool, it allows them to save off a snapshot of the Active Directory database, which could also be viewed offline for gathering additional credential information. And then lastly, the Kerberoasting technique. So what you see there with the last command line is another case where they brought down a legitimate Windows tool, the setSPN tool. And what that allows them to do by executing that command is to enumerate the domain controller for service principal names. And with those service principal names, then you know the services that you could theoretically request a Kerberos ticket for. And that is just one step and part of the overall Kerberosing process, because then when you collect those tickets, you could take them offline for offline cracking. And obviously that's a gross oversimplification of the whole Kerberosing process and technique, but in essence, that's what that element of the overall technique is doing. And subsequent to this, we also then did see them also execute PowerSploit using the invoke Kerberosing module as part of that process as well. Okay, discovery. I am not going to go into a unique example for discovery because there's nothing too unique about the discovery techniques that we see in use. Everybody does it. Obviously, when an adversary gets on to a box, they're going to want to gather account and network information. So nothing too significant to point out. Nothing happens too far out of the usual with discovery. So for time's sake, I'm just going to move on to some of the more interesting tactics and techniques. So we'll talk about lateral movement for our next example. And here we saw a case against a financial institution where an unknown adversary was using the Windows admin shares technique to perform lateral movement. And the examples there, you see actual WMI execution. So why are we calling out WMI? Well, if you look into the documentation for what's considered part of Windows admin shares for that particular lateral movement technique, WMI uses SMB RPC authentication for talking to remote machines. So that's part of the Windows admin shares overall technique. Which is why we're pointing it out here. The adversary wasn't necessarily actually using just straight normal WMI commands. They're actually using an open source post-exploitation tool that's based on WMI called WMIsploit. And that's what you see being used here to run these WMI commands. So in the first example, connecting to a remote machine to update group policy settings, and that's because perhaps they've made changes to the group policy security settings and they want to refresh those, get those pushed out to that machine so they can then take out their intended follow-on actions. So that's what's happening there in the first case. And in the second example, you see them simply connecting to a remote server of WMI to enable RDP so that then they could theoretically access RDP as another intrusion vector there for that machine. Collection, moving here quickly. This time's getting short, so I'll try to go quick. Here we saw a case against a pharmaceutical organization where the adversary used a script to automate their collection. And an example of one of many similar command lines is provided here, where they are archiving a number of different types of document files within a number of different directories. So that's just one example of the script execution that was occurring. You see there that it's executing WinRS, which doesn't make a lot of sense because WinRS is a Windows Remote Services legitimate Windows administration tool, not used for data archiving. So why is it we're seeing it here? Well, the adversary actually is using WinRAR. They just renamed it as WinRS to try and obfuscate what they were doing. So that's really a WinRAR execution. And you notice it's got the ATT&CK flag with a specific date. What that essentially is doing is looking through all these directories to only gather the files that have been added or modified since that date. So this indicates that this adversary has been there for quite a while, and they're coming back on a monthly or quarterly, somewhat probably routine basis as part of their operation to come back and harvest the new information that has been added to this particular victim machine. Okay, exfiltration. This was a Linux intrusion against a global telecommunications victim where the adversary was simply as part of their operation to exfil data using data compression and exfilling over an alternative protocol. That alternative protocol is simply email, as it's considered under the attack framework. In this case, they're using UU encode to encode the archived and compressed files over email to that FTP server. So that's essentially what's happening there. Moving along here. Okay, last example. Quickly, this is in a Mac intrusion, remote file copy and web service. Essentially, the attacker was using an existing backdoor, but for defensive purposes, they wanted to get a new version of it in case it was being discovered. So they just reached out over curl to bring down a new version of the backdoor they were using. And just highlighting this one because it's using a common web service. We've talked about that over the course of this last few days, as well as open source services like Pastebin, GitHub, Microsoft OneDrive. We see these cloud web services being used increasingly for command and control purposes. So that was certainly the case here. And now getting down to our conclusions. So overall, we were successful in establishing this baseline of adversary tactics and techniques usage so that we can more confidently make assessments for how that's changing into the future. And we are excited about that and looking forward to continuing this process of tagging all of the malicious activity with the attack framework techniques that we're seeing. However, our second goal of developing robust and confident adversary profiles was not something we were satisfied with in the end. And we found that because there are adversaries that regularly use the same techniques, a lot of technique overlap occurring here. And there's times where we see the same adversary at different intrusions using different combinations of techniques as well. So there just wasn't enough. Maybe we need to just gather more data and do this over a longer period of time. But at this point, we're not confident enough in our adversary profiles to say that just looking at the tactics and techniques are enough to really help with attribution. You're going to have to go lower. We did find if you get down to that procedural level, those specific implementations of how techniques are being used, then you can really get into some distinguishing characteristics among these commands that are being executed by adversaries. One quick example, if an adversary is creating a new account for persistence purposes, and that new account uses a specific password, well, that password, if they reuse it in different intrusions, which we've seen before, totally separate organizations, they create a new account using the same password, that's a pretty unique characteristic that we can then correlate between. So that's the level that we want to get, that we're using at this point to help with attribution. So we think there is some potential there. And obviously, state of the art when it comes to attribution is primarily custom tool usage or looking for C2 network infrastructure analysis. We know there's limitations to that, but we think with if you use tactic techniques and procedures to help with attribution to develop these adversary profiles, then you're really onto something. So we're looking forward to exploring that analysis further. And with that, I will conclude. Thank you so much for the opportunity, and I look forward to any questions.
Thank you.
And if I use all my time, I apologize. I'm available for questions during the break for sure.
Yeah, since we want to stay in your seats for 1 second, just want to thank Carl for a great talk. And I will just one editorial comment is that one of the things that we're really interested in at MITRE is to figure out how to take that data if CrowdStrike and the other folks in this room who have this kind of data are interested in anonymizing it and aggregating and contributing it, how we can try to provide that global heat map for what people are actually seeing in the wild. I think that could be a significant resource. So you'll be hearing from us.
Great. Looking forward to it.